Chris and I were thinking that, well, Chris should introduce me, but it was going to create a cycle, and it's hard to escape. So, hello, I'm Dan Bickel. I'm a research scientist at Google. I run a project on extracting knowledge graphs from text for specialized domains. If anyone here is interested in that type of thing, please see me afterwards. I'd like to introduce Chris Welty. I'm not going to bore you with the details of his incredibly impressive resume, which you can read online. I mean, he's well-versed in things like natural language processing and knowledge representation and crowdsourcing and many other relevant disciplines. And he's worked with people like Richard M. Stallman, probably Richard Feynman, all the great Richards. I think he did an internship with Keith Richards at one point. Some of this is true. So, no, I'd like to just let you know one thing that happened. Chris and I overlapped at IBM Research, but we didn't really know each other then. I met Chris when he came to Google and gave a talk, and so we met for an hour, and we sat down and started talking about event extraction and understanding from text, which was a research problem I was working on at the time. And within the first minute of conversation, Chris said to me, Dan, I have radical views on how events should be annotated and modeled and evaluated. And I thought, whoa, this is going to be an interesting conversation. And the reason I bring this up is that Chris is not only well-versed in multiple disciplines, but he is also very good and very confident in his ability to articulate them. So with that, I give you Dr. Chris Welty.
Thank you, Dan. I have some radical views on automated knowledge-based construction, which I'm going to share with you today. The title of my talk is Just When I Thought I Was Out, They Pulled Me Back In! The role of knowledge representation in automated knowledge-based construction. So, what Dan didn't mention is that among the many things I consider myself an expert in, one of them is knowledge representation. My background is in knowledge representations, formal representations of knowledge, and I went through various stages in my career, and I'm going to talk about that and then why I seem to be getting back into this place that I started. So, back in my early days, which are a while ago, my primary interest in the thing that drew me into the field of AI was just the idea of building AI systems, building intelligence systems, things you could talk to and get answers from. And this was grounded in something that was written in the or best articulated by something that was written in the early 80s called the knowledge representation hypothesis, which is stated in one of the most roundabout ways of any statement ever made, but which essentially says that knowledge should be captured in a way, in machines in a way, that makes them behave as if they knew what they supposedly have captured. And secondly, that if you looked at that knowledge, you, a person, would understand it. So those are sort of two sides of the knowledge representation hypothesis. And while we seem to have made a lot of advances on the first part, that AI systems and machine learning systems seem to be advancing as far as being able to behave as if they understand some of the things that are being presented with, we haven't gotten very far with the second part. And that was this idea of declarative, symbolic knowledge representation. Though we considered those two things equal. And back in the 80s, yes, I'm talking about the 80s, what everyone in AI was talking about was expert systems, and I became interested, I became involved in how you acquire knowledge from experts. How do you get that knowledge from a person into a machine? And this was an incredibly complicated task. And I personally moved from there largely because of personality, but also just coincidences on who I met with, into a field that later defined itself with the label ontology. Of course, it turned out we had no idea what ontology actually meant. It just sounded like a good word to use for this. This is what computer scientists always do. It's not this, but I actually, because of the label, started getting into what ontology really is, which is primarily a philosophical endeavor. And there are some things that you can learn from the way philosophers think, the way philosophers analyze the world. But you have to be careful. It's a very slippery slope, because philosophers can talk endlessly, and have. I mean, ontology is more than 2,000 years old. The name isn't, but the field, metaphysics, goes back to Aristotle, perhaps even Socrates. So how much progress has been made in that time? Well, here's one of the great metaphysical puzzles. Amounts of matter, physical object, is an amount of matter a physical object? I claimed no. I claimed there are deep ontological reasons why it isn't. I went further to claim that this particularly complex representational puzzle has a right and everything else wrong solution, and I thought this really, really deeply mattered. I wrote numerous papers. My highest cited paper talks about this kind of problem here, where we look at something called identity criteria and try to understand why one particular way of representing the world in a taxonomy-based ontology is correct. I'm not really going to go into the details. If you're hungry for more, I can talk about this endlessly. Proposing that the representation on the right was a better representation because it maintained a consistent notion of identity across the different objects being represented in the ontology. I claimed you needed to know how to do this in order to build information systems. And the basis of that claim was this idea. It evolved, at least in my mind and in the community that called itself the ontology community, over a period of about a decade. Here was the basic claim. If you got two guys who don't speak the same language and they end up stranded on a desert island, they have no common reference point within each other as far as language is concerned. So one guy starts mumbling a bunch of words. There's not very many trees on this island. Where are we going to get food? Something like that. And the other guy has no idea what the first guy is talking about. How would they end up communicating? Well, they have the world in common. That's the idea of ontology. Ontology is not about schema. It's not about syntax. It's not about reasoning. It's about the world. We have it in common with each other, and we have it in common with machines. And we can communicate with people with whom we share no common lexical terms by pointing, by gesturing, by touching, by indicating things in the real world and labeling them with whatever words, and eventually we can start to learn how to communicate with each other. And this was the idea of ontology, this idea that if you had some common reference point, you could integrate, and some of my slides are missing. And if you don't have that common reference point, it makes it much more difficult. If you, what happens? Sorry, I seem to have lost one of my slides. Oh, here we go. They're just out of order. This happens with a touch screen. Okay, and so the idea was, if you go around into the world and mandate that everyone use the same ontology, then you wouldn't have this problem of silos. You wouldn't have this problem that data in one repository can't be used by someone who's built their software around another repository because they lack any terms in common. But the idea of building one single ontology that everyone in the world uses is like electing a single form of government or something like that. It's just impossible to get people to agree on what that single form of ontology is. But if we adopt a practice by which people model based on the real world, it makes the problem of communicating between two different reference schema easier because they're both based on the same ideas about the world. That was what ontology was about. It was about how human communication is ultimately grounded in the real world and that we should design systems on that assumption. And what finally happened to me as part of this curating this message was I realized I didn't really care about that. I got into this because I was interested in AI. I wasn't interested in making database systems interoperate. Ontology and building proper ontologies was really all about gathering consensus, finding points of agreement, finding, not concentrating, in fact, avoiding the discussion of how to name things until the very end. To first begin by identifying the different kinds of things that mattered in some application, in some domain, understanding and arguing about what the distinctions are, and then naming them. Because when you argue about names, it's a useless argument. It doesn't matter what you call it. It matters what it is. And again, I started realizing that I didn't really care about those discussions. I hadn't gotten into this game because I cared about getting databases to interoperate. What I cared about and what I really wanted to do and what I was incredibly passionate about was building AI systems. And so I moved from the KR hypothesis, which, at least from my perspective, about now a little over 10 years, maybe 15 years ago, was something I had gotten drawn into. I moved to this text hypothesis, which I'm sure a lot of you are familiar with. The basic assertion, never really been proved, but probably most of the people in this audience believe that 80% of the world's knowledge is expressed in text. And I got involved in a relatively famous project to build a question answering system that could compete on Jeopardy, and began to focus my efforts, as well as a 30-person team of people, into how we could answer questions from text in order to compete on Jeopardy, but in general, in order to build an advanced question answering capability like nothing that existed before. My particular team in Watson was focused on semantic knowledge-based services. I can't remember, I don't remember the name of the team. But anyway, we were doing research and we were doing engineering in trying to get a lot of the existing structured repositories of knowledge, because that was my expertise as a result of all that time I spent in ontology. But I was really interested in the role that these artifacts could play in getting answers to questions. We tried a lot of different things, but the four that actually worked in Watson for Jeopardy now I'm talking about, which I don't know what, I now work at Google, I don't really know what Watson is doing today, if Watson even exists in the form it was in when we played Jeopardy. But for Jeopardy, what the kinds of knowledge, the kinds of structured declarative knowledge that worked in Watson was for typing. We wanted to type answers. A lot of Jeopardy questions have types in them. And working now at Google, we see that even for user-phrased questions, we do get a lot of very indicative type information. So being able to reliably say what the type of some potential answer to a question is was extremely valuable. It was worth, these are rough numbers, I don't remember the exact ones, they're published. Something like 10% of our performance was due to the ability to reliably type the answers, okay? Just the answers. Look at a candidate answer and see if it's of the right type that the question was asking for. The second most important and valuable service that we provided here for Watson was identity. Identity is really tough, and it was of interest to me because of my background in ontology. Most of the work that I had been involved in ontology was about identity, was about how you characterize categories of objects by understanding and discussing what the identity criteria were for members of that category. This is an important issue in philosophy. And if you look at any publication in the philosophical side of ontology, or now as it's called metaphysics, because computer scientists dirtied the word ontology, so philosophers don't call it that anymore, it's all about identity. That's all they talk about. Identity is the key to understanding different approaches to metaphysics. For a knowledge graph, like DBpedia or Freebase, now Google has a big knowledge graph, Wikidata, identity is, to some minds, the primary purpose of that graph, to provide the ability to give a unique identity to different entities that we care about. And so for Watson, being able to do that was worth about 8% of our performance, rough numbers. And these four numbers overlap with each other. These were based on a single component ablation studies. The next one, which was useful, was being able to do relations, being able to have a repository of relations between entities. But notice the last two rows. In less than 1%, and less than 0.5% of Jeopardy questions were we able to actually find the answer using only the graph. Now, this is much less true for Google's question answering service. I mean, we get a lot of people ask the same question over and over again. Jeopardy has never duplicated a single question. So it makes sense for Google to sort of curate the head of those and build a graph that answers just, here it is. This is Molly Cyrus's birthday. That seems to be what everyone cares about. Here you go. Here it is. Why gather that one from text once it's been asked 10 billion times? But for us, the answers to questions were rarely in the graph. But what did matter was being able to say when something's in a particular country or state, when two states border each other, just as ways of processing the information and clues that were given in the question. So answers, not so much, but having some repository of relations was useful. And when Watson won Jeopardy, I don't know if you guys knew that, but we won. After we won, we moved on to healthcare, building. It was a little vague what we were really doing, something to do with medical. My team moved to kind of a very straightforward AKBC kind of approach. Can we build the biggest medical knowledge base in the world with, I think we had 12 relations that we cared about, like what are the symptoms of various diseases, what are the treatments for those diseases, and so forth. And so we started looking at gathering this knowledge, still the text hypothesis, so assuming this knowledge is in text. And interestingly, I don't know where exactly this data is coming from, but my student Anko Dumatraki was listed as the second most frequent publisher in relation extraction. Relational extraction? What was that term? Anyway, that was used in the first talk. All right, and one of the things we stumbled upon when moving into the area of relation extraction was some work that we ended up calling crowd truth that some of you have seen, although nobody's actually used, that talks about getting answers from the crowd and recognizing that there is sort of a spectrum of truth. Now, people who've been using soft approaches probably understand this, but surprisingly, even people who use soft approaches still use these very concrete and discrete ground truth representations to measure the performance of their systems. So here we were talking about a relation extraction system based on distance supervision, so we already knew that malaria and chloroquine are related, that chloroquine is a treatment for malaria. That was known. So we're finding all sentences that mention those two things, and there were a lot. And we're hoping, of course, to build up a capability from this to understand when medical text relates a drug and the disease it treats, so we can get the ones that we don't already know, right? That's the hypothesis behind distance supervision. Well, we took some of these, and of course, some of these sentences, some of these distance supervised sentences, and not all of them are true, as anyone who's done distance supervision knows. So we ran it by, this is medical, right? So, I mean, we can't be wrong. We got to use experts, right? Because they know what they're talking about. So we're going to ask experts what they think about these sentences. And we're going to say, you know, we've labeled these sentences with a disease and a drug. Can you just tell us if the sentence expresses the treats relation? And so we gave it to a bunch of experts. These were medical students in their third year, so you know, legitimately medical experts. And one particular expert labeled these three sentences this way. So the last one, this person did not consider to be expressing the treats relation, although the second one he did. The first one is pretty clear and obviously expressing it. And what we discovered was medical experts are expensive. Is there some way we can get around using them? Not only are they expensive, but they tend to be a little bit high-strung. Can we use something a little bit cheaper, more scalable? The crowd. So we started doing some crowdsourcing. And one of the interesting things we found was that if we sent the same sentences, the exact same sentence, to more than one people, instead of trying to optimize our overall throughput by giving one sentence to one person and then, you know, checking the whole thing for inter-annotator agreement, to just give, you know, the same sentence to 10, 15, 20, 50 people and see what we get. And actually this came out of the work that Dan had mentioned for event extraction. Because when we were working on event extraction for the machine reading program, nobody had any idea what an event was. Nobody had any idea how to put them in a timeline. No one could recognize the difference between a correct timeline and an incorrect timeline. How do you measure it? How do you score it? No idea. And if you flip over into the stuff I used to be interested in called ontology, experts in events range from thinking that every single thing in the world is an event, including you and me, to there is no such thing as events. How does that help? So we started using the crowd, and here what we saw is when we use the crowd, we get a range of opinions, and we get something a little bit more useful than asking a single expert. What I get from this is that the third one isn't utterly wrong. So among 56 subjects reporting to a clinic with symptoms of malaria, 53 of them had ordinarily effective levels of chloroquine in the blood. Ordinarily effective. I mean, that seems to imply that chloroquine is ordinarily effective. For what? It doesn't say for malaria, but come on. All right, so what the crowd tells us is this one isn't totally wrong, whereas our experts said, wrong. The middle one is better. It's still not a perfect declaration of the treats relation, but still, when someone says something like that, it's probably because the drug treats the disease. So we were getting something here. We were getting a signal from asking the crowd to do this task. We were getting something from the disagreement. So we started looking at the disagreement. What we ultimately wanted to be able to conclude from the disagreement is the last sentence sort of expresses this relation, but not as well as the middle one, is not as well as the top one. So if I'm building a capability to mine text for medical relations, I should know that. But of course, not all disagreement was due to that. You know, if you have paid any attention to crowdsourcing, you know that the vast majority of disagreement is caused by lazy, spammy workers. Problems with the sentences themselves. I mean, it's distant supervision. You get lots of garbage there and so forth. But one of the interesting problems was with the target semantics. The workers disagreed when they didn't really understand what the relation meant. So there's a medical relation called associated with. Most medical professionals know what it means. It's sort of a kind of set of symptoms that are associated with the disease, but there's no known causality. That's what associated with is supposed to mean. But in English, it's such a soft and vague term. And in medical writing, they use associated with in its English meaning all the time. They just know which one is which because they know what symptoms are associated with what drugs. And one of the points was that each one of these kinds of quality, worker quality, sentence quality, and then the target relations in the case of relation extraction, that quality, they all affect each other. A worker who gets a really unclear sentence, that sentence is going to cause a lot of disagreement because no one can figure out what it says. And now, is my worker going to look like a spammy worker because the worker didn't agree with the others on that sentence? And when they have to annotate unclear relations, it's going to cause disagreement. And this is the sort of the bringing me back part. Because when people disagree, because we observe that people do disagree when the schema is unclear, when the relations you give them are unclear. So in the TAC challenge, there were a bunch of relations that humans had a hard time annotating consistently. It wasn't really clear what they were supposed to mean, especially when you made the leap to language. And here's an example of what does Italian mean in this sentence. Does it mean they were born there, they lived there, their mother was Italian, their grandmother was Italian? Legally in Italy, that's all it takes. Your mother's mother only. Sorry, I'm making fun of Italians, no offense. People disagree when the amount of inference that they're expected to make is unclear. So some of those sentences I showed before. So Hong Kong lawmaker Emily Lau, she's a lawmaker in Hong Kong. Is she born there, resides there? Am I allowed to conclude that? She probably resides there, right? Maybe not. Maybe she just works there. Maybe she's American. You know, who knows? Can I make this leap of faith? Are they allowed to? And then, interestingly, and most tied to the work that I'm doing recently, when the taxonomy is unclear, people have problems really understanding how to use it and how to label. So this is an extract from Google's product taxonomy, which you can download yourself if you're interested on Kaggle. And this is the kind of problem used to drive me crazy. I mean, I would be twisting people's necks off. How can you have non-dairy cheese under dairy? Crying out loud. What's the matter with you? Don't you know what non means? Not only that, but non-dairy cheese is a subcategory of cheese. Non-dairy milk, however, is a sibling of milk. You know, I mean, if you're going to make mistakes, you might as well make them in every possible way. Here, not to pick on mesh, but my own drawing capability. Anyway, that circle was supposed to be around heart. Heart, the notion of a heart is reproduced throughout mesh. Mesh is subject headings for classifying medical research articles in PubMed, and heart appears all over the taxonomy. It keeps getting duplicated because sometimes the taxonomy means like parts of the body, and sometimes it means something that's being affected, and sometimes it means something else. And when we try to get people to label these things, they don't know what to do. They get extremely confused. This is a terrible basis to make these kinds of decisions. And one of the concrete experimental results we had was that in our studies we found that not only, so let me start over again. One of the things we found experimentally was that when people disagree on what the right answer was, it was also harder for machines to figure out what the right answer was. It makes sense, but it's also good to know. So when it's confusing for people, it's going to be a hard target for machines to learn. It makes sense that it should be that way, but we have some empirical evidence that shows. I don't have time to really explain the graph. Trust me, that's what it says. And so really, I'm going to wrap up here with this idea that this remains thought-provoking, but I don't have anything to actually finally tie these two things together. But the idea to think about is sometimes we have some evidence that unclear semantics on the declarative side causes confusion among people when labeling. It makes it harder for machines to classify, and that cleaning up some of these artifacts might make a difference. Thank you.
If you could please illuminate your thinking around how people actually use language in the real world, which of course you can study, and the notion of ontology as you described it, right? You can get a community of discourse together. They can agree on an ontology, but they may not represent the way people actually use language. So do you today care more about how people actually use language and basically say to yourself, that's the ontology that really matters and that's what we're going to use? How do you think about that?
That's a good question. I didn't emphasize this, but it was on my slide. Another one of the reasons why I got out of ontology was because it just couldn't be measured. It was just incredibly frustrating to someone like me to not be able to come up with some kind of concrete evidence for why one thing was better than another. This is this kind of thing where people argue about literally for thousands of years. And that's frustrating. I do think how things are expressed in language is an important part of the equation, and one of the things that gets confusing. The treats relation is a great example of that. Doctors think they understand what the difference is between the treats and the prevents relation when it comes to drugs. So preventative treatments are different than treatments, but when used in text, they use the same words to describe them. So they're not using it in as formal a way as they think actually exists in their heads and in their training. So it's going to be important to reconcile those two things.
All right, one more question at the back.
So I think those kind of weird taxonomies that you were showing with the 9 non-dairy milk happen because they start with a taxonomy that makes sense and it's orthogonal and easy to label. And over time they're, oh, but we can use it for this other thing, instead of tearing it all down and building a new one that's clear to use. And what are your thoughts on when to break off and when to adapt?
I spent a lot of time studying many different ontologies, and they all have problems like this. I mean, there's no exception at all. The best ontologies have about 8 things in them. That's about as far as you can go and be clear. But you can make progress, but there is a point of diminishing returns. I agree. I could talk about it for a long time, but I mean, I think there is a balancing act that has to go on. But there's a lot of cases like this where it's pretty clear it could be improved.